huge array. This is some enormously huge number. Much, much bigger than Z prime that we had a few videos ago. Okay, let's just have a look at what the next one would be. 3 star n plus 1, 4. So again, by definition, that's 3 star n, and then multiplied by 3 star n plus 1, 3. That should be a 3. That too should be a 3. There we go. And so what we're getting here is what we just calculated at the previous step, which is this 3 star 3 to the 27, 3 to the 27. And now we still have the star n here, so we have to replace the n here with this second sort of exponent. So here is 3 star 3 to the 27, 3 to the 27. That whole thing is the subscript under the star now. And then we have to, again, multiply that by the same thing here. So it's a similar kind of thing as we had here, except that the huge number that we obtained here is now the index for our star here, those being the exponents here, the second one. So this is vastly bigger than this one. It's almost incomprehensible how big this is. But these are still early days. This is still relatively modest compared to the things we're going to be seeing shortly. Great, so now we can go further. We can extend our hierarchy. We've had this row already, and now we can take the successor of star n to get star n plus 1. And there's no reason why we can now not take the successor of star n plus 1 to get star n plus 2, let's say. And the successor of star n plus 2 is star n plus 3, and so on. So we get a new sequence of operations, sort of built from star n, in a similar kind of way as these original ones were built from plus. And now a new idea suggests itself, that we can take the limit of this new sequence. So the sequence star n plus 1, star n plus 2, star n plus 3 also has a limit. And we're going to give that the name star 2n. Okay, so let's have a look at what that means in terms of a limit. The actual definition doesn't have any kind of limits involved. Okay, it's important to realize that we're not taking some infinite process here. We're not having to do something infinitely like a limit in analysis. So it's not a limit like an analysis. But nevertheless, we're still using that word, so confusion possibly arises. So the definition here is very, very concrete. Star 2n. We're defining this operation very concretely. Here's a natural number m, here's a natural number k. And I'm telling you how to multiply m with k with this operation star 2n. Okay? And the definition is that what you do is you take this k and you replace 2n with n plus k. In other words, you go to the kth operation in this sequence that defines this limit, and you choose that kth one. So here's the first one, here's the second one, here's the third one. The kth one is star n plus k. So we take that kth operation that defined our limit, and we apply that operation to both m and k. So we define star 2n now in terms of a previous operation, but which previous operation it is depends on k. So for example, if we had to calculate 10 star 2, 10 star n plus 3 times 3. And then we could try to simplify that because this is a successor, it's a successor of n plus 2, so we could write this as 10 star n plus 2 times 10 star n plus 3, and then subtract 1 here, 2. And we could then, just by going, try to unravel what this thing is. It might take us quite a long time to unravel what it is. Okay, so now an exciting prospect emerges that we started with our first row to get our first limit, star n. They're all operations. And then we took successors of star n, we got a new sequence, and we took its limit, which we call star 2n. Now, of course, there's nothing to prevent us from taking successors of this one, and they're going to be called star 2n plus 1, that's the first one. And then the successor of that will be star 2n plus 2, and then star 2n plus 3. Now we have a new sequence of operations. We can take the limit of this sequence, and we'll get star 3n. And we can keep going here, right? Give me the 4th row, 5th row, 6th row, and so on. So we're getting all these new limits. So let's actually circle them just to make it very clear. So these are kind of new kinds of operations that are different in character, essentially different in character from these ones. These ones are all successors. Each one of these is a successor of something that had gone before. These ones are not successors, they're limits. And notice I have put a little colon beside them. That's some kind of notation that we could use to alert us to the fact that this thing here is actually a limit, not a successor. Okay, and now you might say, well, here's a lovely hierarchy. Right? We've got this sort of potentially ongoing grid. We can just keep on adding more and more rows, and we can get bigger and bigger operations. Fabulous. That's good. But in this story, whenever you have some kind of pattern that you're comfortable with, you can go beyond your comfort zone. You can go to the next level. You may not want to, but you can. Okay. And in this case, going to the next level requires a shift of thinking. In fact, it almost always requires some kind of shift of thinking. You have to think in a little bit different way than you have been up to that point. So we're going to think a little bit differently. We're going to say, well, we created these new kinds of operations. They are limit operations rather than successor operations. Okay, so now we have a new type of sequence. Namely, these green ones here, they themselves form a sequence of operations. They themselves form a sequence of operations. And so we can take their limit. We can take the limits of these ones. along rows. And now we're taking the limits of those rows and regarding them as a column and take the limit of that. So here's star n, star 2n, star 3n. These can be used to generate a new operation called star n squared. Star n squared. Now what is the definition of star n squared? Well, it's the same kind of thing that we've seen before. We always define a limiting operation on a sequence in the same way. So once we have our sequence clearly in mind, then the definition of the limiting operation is completely cut and dry. So m star n squared k. We're going to multiply m and k with this operation. So what do we do? Well, we regard this as being created in some limiting fashion from this sequence. And what we do is we take the kth element in the sequence. Look at the second exponent here, the second operand, and we take the kth element in the sequence. This is the first element, this is the second element, that's the third element. So the kth element will be star kn. And that's what we do to m and k. We multiply them with the operator star kn. That's already defined. It's already in existence. We're using it to multiply m and k, or maybe we should say exponentiate m and k, whatever. Okay, so this is quite interesting now. So a new kind of limit is at some point have a higher limit than these ones, because it's a limit of limits. So for example, we might now ask, what is 3 star n squared 4? That's just a number. These are numbers, and this is an operation, like exponentiation or triangle operation, but somewhat fancier, somewhat more complicated. The definition here tells us that we need to interpret this by thinking of replacing the n squared here with a 4 operation which defines this as a limit. So it becomes 3 star 4n 4. Alright, now it's an excellent exercise for you to pause the video and go off for a few hours, and a few hours probably, at least, and try to see if you can get your head around what's happening with this number. We want to evaluate this, or at least move towards evaluating, trying to figure out what does this number actually look like in some fashion or another. So we want to sort of strip away these various recursions, and the review of the number itself will be very big. So this is an excellent exercise to do this, so please have a go, and then you can compare what I'm going to show you in a minute or two. Alright? Let's see if we get something comparable. Alright, so let's see if we agree on what we get here. And find out my best in trying to work this thing out, but I do admit that this kind of thing gives me a headache after a little while.